David Spears, civil engineering instructor at Texas Tech University. I've got another 2D rigid body equilibrium problem for you, this one with a hinge in it. And I want to remind you that whenever you see those words, 2D rigid body equilibrium, that you think of the three steps, which I've drawn here in blue. And they are to do a free body diagram, get everything in Cartesian form, and then do sum of moments and sum of forces to solve those for the unknowns. Okay, what we have here is the setup is that we have a beam from A to B with 4 kips in the middle, and then a hinge at point B, and then a vertical member from B, C, D, and on it we have a 1 kip load 2 feet down, a roller at C, and 2 kips to the left force 2 feet above the point D at the bottom here where I have a pin. Okay, with these problems with the hinge in it, it's kind of like a simple frame. I need to split it up and have 2 free body diagrams and analyze them separately and remember Newton's third law. So let's do a free body diagram first of member AB. And at point A, I have a roller, so all I have is a Y force. At point B, I have a hinge, so I can have no moment, but I can have both a Y force, which I tend to assume up, and an X force, which I tend to assume positive to the right on the first member I come to. It doesn't make any difference as long as I reverse them on this other member. And then I have in the middle my 4 kip load. Remember that that's 4 feet and 4 feet. Just write that to remind myself. Then I go over to member BCD, and however I drew these reactions that I assumed at B on member AB, I then assume equal and opposite, because that's Newton's third law. So I assume BY up on AB, so I assume it down on this member. I assume BX to the right, so I say it's to the left on this one. Got to be careful and reverse my signs if I get negatives, reverse my arrows if I get negatives. And then here in the middle I have a roller at C, so I need to just have a reaction perpendicular to the surface that roller is resting on, because it resists X forces, and so I put a reaction there, CX. And then I go down to the bottom where I have a pin, and that resists X and Y forces, so I've got dy and dx to replace that pin support at the bottom. I've also got my applied forces, my external forces of 1 kip, 2 feet down, 2 feet to C, 2 feet down further. I have a 2 kip load, and that leaves me 2 feet to the bottom, to D. So there's a good free body diagram. Remembering I've reversed, the key thing is to break it up into 2 free body diagrams and reverse those forces at the hinge at B. Now I'm ready to do well, if I had any Cartesians to figure out, but it's pretty straightforward, just X and Y forces and dimensions. Don't really need to worry about the geometry of this one. So I'm ready to go to some moments. I'm going to deal with free body of AB first. And for AB, I want to sum moments about some point to eliminate unknowns. So I'm going to sum moments about point A. I could do it about B also, but I just arbitrarily chose that one. I do want to be careful, and there's a lot of times where you can make your life easier and the solution faster by carefully selecting what point you sum moments about. some moments about point A. Show my sign direction assumption positive, counterclockwise. Start at A, well, AY has it intersects the point, so it has no distance, so it goes to 0. And then I look at the 4 kip, it's trying to create clockwise rotation. So it's a negative 4 kips times 4 feet. Then I look at point B, well, point B, force BX intersects point A. It's an X force with a 0 Y distance. So it's BX times 0. Creates no moment because it intersects point A. And then I have BY acting up would create a counterclockwise rotation, which would be positive on my sign assumption. BY times 8. So it's pretty easy. I've just got negative 16 plus BY times 8. Rearranging, I have BY is equal to 16 positive divided by 8 is equal to 2 kips. Well, it's pretty easy to see by inspection. I've got a 4 kip load in the middle of an 8-foot span beam, and right in the middle, half of it's going to go to the left to AY, half of it's going to go to the right to BY. And so I'm kind of giving away the next step, but that's just the sum of the forces in the Y direction. Positive is up. Show that 0. AY assumed up, so it's positive, plus BY, which was 2, which is positive up. Therefore, and then minus 4 for my applied load. Do the math, I get that AY minus 2 equals 0, so therefore AY equals positive 2 kips up. Forgot to show my arrow and box my answer. The positive number for BY means the direction I assumed up is correct. Put a box around it. Same thing with AY. Assumed up, I got a positive answer, so it is up. Real easy to do sum of forces in the X. That's by inspection 0. Positive to the right. Only thing I have is BX. So BX has got to be equal to 0. No other X forces on there. So now I've got AY, and BY. So I want to, and my signs assumed on the free body diagram for AB are correct, so I want to put those numbers, or at least for BY. If it was up on AB, it's down on BCD, so it's 2 kips down correctly. BX went to 0. So now do the same thing for BCD. Some moments about some point, I will logically choose point D. Some moments about D is 0. I've got, starting at the top, the 2 kip reaction from BY has a 0 X distance, so it goes to 0. Then I've got this 1 kip applied load. It's trying to rotate, I hope you can see, clockwise about point D. So it is negative 1 times 2 plus 2 plus 2, or 6 feet. Then I've got CX also assumed in the same direction to the right, so it creates the same kind of moment clockwise. It's negative CX times 2 plus 2, or 4. And then I've got this 2 kip load down here. It's trying to rotate counterclockwise, so it's going to be a positive moment by my sign assumption. 2 times 2. Do the math, and I've got negative 6 minus CX times 4 plus 4. So I've got negative 2 minus cx times 4. Rearranging, that's all equal to 0. Therefore, cx, take that negative cx to the other side of the equal sign. I got cx times 4 is equal to negative 2. Got to be real careful with your negatives. Cx works out to be negative 2 divided by 4, or negative 0.5 kips. The negative sign means my direction assumption here to the right was opposite, so it's really to the left. I boxed that answer. Don't want to ever box a negative sign. I want to show the direction of these 2D problems with arrows. Finally, I can do sum of forces in the x while I'm at it. Positive to the right, and I get that's equal to 0. Looking at my free body diagram, Bx is 0, start at the top. Then I've got positive 1, and then I need to reverse this arrow before I forget it. It's really going to the left for Cx, so it's negative 0.5 Cx. I recommend reversing those arrows on the free body diagram, kind of making a note to myself the direction I assumed is opposite. Then I've got negative 2, and then I've got dx positive assumed to the right. Combining these numbers, I get negative 2 plus negative 0.5 minus or plus 1 is going to be negative 1.5 plus dx. Therefore, it's equal to 0, so dx is equal to positive 1.5. Positive means my sign assumption, direction assumption of to the right is correct. Show it like that. And then finally, sum of forces in the y. That's equal to 0. Positive is up. Start at the top. I've got negative 2 from by. And then the only other y force I have is dy, which I assumed up. Therefore, dy works out to be, obviously, positive 2 up. 2 kips. Put a box around that. So that's the key on these hinge problems, to split them up into 2 separate free body diagrams and use Newton's third law, which is equal and opposite forces, and reverse the directions on the free body diagrams. Be consistent with when you find a negative answer, show it